You are welcome back. So this is the continuation of limit of accuracy. So the next topic is percentage error. And under percentage error, we are going to be looking at the definition of terms. So we have some terms you people need to know under percentage error. Then we have examples on percentage error. So let me start with the first objective, which is definition of terms. So under the definition of terms, I'm going to look at absolute error. And what is absolute error? Absolute error is simply means the difference between the measured value and the actual value. So absolute error simply means the difference between the measured value and true value or actual value. So I'm going to write that. So absolute value is the difference between the measured value and the actual value. So this absolute error can be positive and it can be negative, depends on the lower limit and the upper limit. Then the second one is relative error. So relative error, which is RE, we can get this relative error by dividing the absolute error by actual value. So that is the simple definition for relative error. So we obtain the relative error by dividing the absolute error by the actual value. So relative error is obtained by dividing the absolute error, so I'm using AE for absolute error, by the actual value. So this is what? Relative error. While the main topic, that is the percentage error. So the percentage error which is PE, is given as, so percentage error is given as, we multiply the relative error by 100. That is percentage error. So multiply the relative error by 100 is given by multiplying the absolute error, the relative error, by 100. So these are the terms under percentage error. So the first one is absolute error, second one is relative error, third one is percentage error. So these are the definition of terms. So the formula now to calculate the percentage error is now, so mathematically, percentage error, PE, is given as relative error multiplied by 100%. And what is relative error? Relative error is the difference between the relative error is obtained by dividing the absolute error by the actual value. So this can also be written as absolute error all over actual value multiplied by 100%. So in this case, relative error, which is this, is the same thing as absolute error all over actual value, then multiplied by 100. So the formula to calculate the percentage error is now given as absolute error. And how do we get the absolute error? The difference from the measured value and the actual value. Then all over actual value multiplied by 100%. So that is that on definition of terms. So we now move to the examples on percentage error. So after the first objective, that is the definition of terms, so we have these examples. So the question 1 says the weight of a book is given as 1.1 kg, but the actual weight is 1.24 kg. So what is the percentage error? So if you go by the formula given under percentage error, we have percentage error to be equal to absolute error. So we have, but before we do that, let's try to write out the data given. So solution. So the data given, the weight of a book is given as 1.1 kg. So that is measured weight, which is 1.1 kg. But if you look at the question says the actual weight is given as, so the actual weight is 1.24 kg. So we now we are looking for percentage error. So percentage error PE is unknown. We don't know it. So before solving for percentage error, we need to know our absolute error. And what is absolute error? So absolute error equal to difference between the measured weight and actual weight. So actual weight is given as 1.24. So we have actual weight minus measured weight. So actual weight is 1.24 kg minus 1.1 kg. So
equals 0.14 kg.
So this is absolute error. So to now get the percentage error will now be equal to absolute all over actual. So multiply by 100%. So we have absolute, that is 1.14, all over actual value, that is 1.24 multiplied by 100%. So we have.
So by the time we divide 0.14 by 1.24 multiplied by 100%, we're going to have 11.29%. So approximately to one decimal place will be 11.3, because the next digit after 2 will be 9, and 9 is above 5, so we round it up. So we add 1 to 2, making 3. So that's why we have 11.3%. So this is where we're going to stop under this topic. So if you find this video useful, kindly give us a big thumb up and then subscribe to our channel. You notice that we lost the voice. That's why I have to put my voice over this video. So thank you for your attention. We'll meet in the next video. Bye for now.